So welcome back. We're going to continue with a system of equations, and we're going to move into a strategy 2 called the substitution method. The substitution method is going to be more of an algebraic way of working the problem out. Here's my system. I have 4x plus 2y equals 10, x minus y equals 13. What I'm looking for is that ordered pair that they both have that makes both of them true. Now, one way of doing that is just find the point of intersection so I can graph these. So if I graph these, starting with this first one, I'm just going to, since they're in the standard form notation, I'm just going to find the x and y intercepts. So to find the x-intercept, I have this 4x equals 10, divide by 4, so 4x would equal 10. I'd have 10 fourths, that'd be like 5 halves, that'd be like 2.5. Okay? The y-intercept, I set x equal to 0, so I get 2y is equal to 10, so y is equal to 5. So that's going to be the x and y-intercept of the first line. The second equation, I set y equals 0, I get x equals 13. So the x-intercept is 13. And if I set x equals 0, I get negative y equals 13. So y would equal actually a negative 13. So if I flip both signs, I get my y is equal to negative 13. So now I've got the x and y intercepts. So let's graph the first one. So I have my x-intercept is 2.5. So 2.5 would be located about there. Y is equal to 5, so that's a little easier to do. I can now draw that line. So now let's turn our attention to the other one. My x-intercept is 13, so that looks like I barely got that on my graph. You can already start to see an issue with graphing. I can get stuff that doesn't even fit on the graph. I'd really have to start messing with my scales to make that work. My y-intercept is negative 13. That's going to bring me down to about here, it looks like. And it looks like these two lines are going to cross. So if I can get those two lined up for me. So from graphing, we kind of see that they do intersect at this spot right here. It looks like that's going to be a 6. Looks like a 6, negative 7. So a 6, negative 7. So write 6 and 1, 2, 3, 4, 5, 6, 7 down. So that would be the ordered pair they have in common. Okay. So that's how I could do it from a strategy 1, which was graphing. Strategy 2, we want to use what we call the substitution method. So this kind of outlines what we're looking for in the substitution method. So step 1 is to solve one of the equations for either x or y. So I want to solve one of these equations for either x or y. What I'm looking for is the variable that does not have anything in front of it. That's going to be the easiest variable to isolate. Notice how the first equation has numbers in front of the x and the y. So I want to hold off on that if I don't need to use that one. Look at the second equation. Notice that x does not have anything in front of it. So I like this equation best because that's the path of least resistance. I can get x by itself rather easily. So I'm going to write down x minus y is equal to 13. And to get y by itself, I'm going to zero out this y with a positive y. And so I have that zeroes out. You have x equals then y plus 13. So I've got my equation solved for x. You notice that it equals some type of expression. Now what I want to do is substitute the expression into the other equation. So what I'm going to do now, the other equation, See how x equals y plus 13? So what I'm going to do is, where there's this x, I'm going to replace that x with, this equation up here, choose the other equation. So I have this equation, 4x plus 2y is equal to 10. And what I'm going to do is, since x equals y plus 13, I'm going to replace this x with y plus 13. So what I'm going to have then is 4 times the quantity y plus 13, and then I have then plus 2y is equal to 10. By substituting in like that, what I'm ending up with is an equation with one variable. And we've done a lot of that in our previous sections. We should be able to solve this equation for y. So we can distribute the 4 through the parentheses. We now have 4y plus 4 times 13. Looks like 52. Plus 2y is equal to 10. We now see that these are like terms. 4y and 2y will give me 6y. So 6y plus 52 is equal to 10. So we're just doing some algebraic manipulations. Now I can solve for y by first zeroing out the 52. So I can use a negative 52 on both sides to zero that out. So now I can see that 6y is going to equal then a 10 and a negative 52 would give me a negative 42. And then if I divide each side by 6, I get my y by itself, and I get a negative 7. And notice how over here, our x value was a 6, our y value was indeed a negative 7. So I'm feeling pretty good about this answer, because that's actually matching my graph. So I can approach this problem using a different strategy altogether. So I substitute into the expression, I then solve for the variable, I got y equals negative 7. My last step is then to substitute to solve for the other variable. So notice how x equals y plus 13. Oops. X equals y plus 13. Since I know what y is now, I can replace this y with what I said y is equal to. And I can write down x is equal to then, I can replace this here in for y, so I can change that to a negative 7, and I'm adding that to a 13. Therefore, x is going to equal a positive 6. And that plays out with what we have over here. So the ordered pair can also be found by using algebraic strategies. So 6, negative 7 would be our solution. So again, a lot of times you'll see the solution written as an ordered pair. Since we're talking about an x value and a y value, that ordered pair is usually how your answers are going to look like. So we'll leave it like that. Okay? So that's how we can approach this problem using what we call the substitution method. So I can get the same answer, but notice that this is going to be more feasible if I start to work with harder numbers. This is going to be not a very fun strategy if I have a lot of hard numbers. The graphing will become almost impossible. That's why the algebra becomes a really nice strategy. Plus, algebra is programmable, which means you can start using technology to do problems. So stay tuned, and we'll see what other example we can come up with for the substitution method.